Hey there everyone, welcome back. Today we are discussing the question number 4 from chapter 8 Trigonometry exercise 8.3. In the previous video we have discussed the question number 1, 2, 3 from this question, and now this is the fourth one. We need to prove 1 plus secant a by secant a as sine square a by 1 minus cos a. It's a pretty simple question. Taking the LHS, this becomes 1 plus secant a by secant a, which can be written as 1 plus 1 by cos a by 1 by cos a, as we know that secant function is the inverse of cos function. Now this can be further written as cos a plus 1 by cos a by 1 by cos a. That becomes 1 plus cos a, as cos a gets cancelled here. Now this 1 plus cos a can be taken as 1 minus cos a by 1 minus cos a, as these two gets cancelled and there will be no impact. And now this can be written as 1 minus cos square a, as this is in the form of a plus b into a minus b, and this is 1 minus cos a. Now we know the identity that sine square a plus cos square a is equals to 1. So sine square a can also be represented as 1 minus cos square a that we have here. So this becomes sine square a by 1 minus cos a, which is actually the required RHS. Now moving on to the fifth question, we are asked to prove cos a by cos a minus sine a plus 1 by cos a plus sine a minus 1 is equals to cosecant a plus cot a. Let us take the LHS, that is cos a minus sine a plus 1 by cos a plus sine a minus 1. Now we are also asked to use this identity, that is cosecant square a is equals to 1 plus cot square a. So let us divide the numerator and denominator by sine a. That becomes cos a by sine a minus sine a by sine a plus 1 by sine a. Similarly, we divide the denominator with sine a. So this becomes cos a by sine a plus sine a by sine a minus 1 minus sine a. Now this thing can be again written as cot a, as cos a by sine a is equals to cot a minus 1 plus 1 by sine a is equals to cosecant a, as they are inverse functions to each other, and then this becomes cot a plus 1 minus cosecant a. Okay, so now we are given with the identity, that is cosecant square a minus cot square a is equals to 1. We just need to substitute this identity at this one. So the equation becomes cot a plus cosecant a minus cosecant square a minus cot square a by the denominator remains the same, cot a plus 1 minus cosecant a. simple. Now write it like cot A plus cosecant A minus, this is in the form of a square minus b square, that can be written as a plus b into a minus b, that is cosecant a plus cot A into cosecant A minus cot A by cot A plus 1 minus cosecant A. Now from here cosecant A plus cot A can be taken as common. Cosecant A plus cot A can be taken as common. This becomes 1 minus cosecant A plus cot A by cot A plus 1 minus cosecant A. And now as you can see, these two expressions get cancelled, and at last we are left with cosecant A plus cot A, that is nothing but the required RHS. The sixth question, taking the LHS, root of 1 plus sin A by 1 minus sin A, we just need to rationalize, that is root of 1 plus sin A by 1 minus sin A into 1 plus sin A by 1 plus sin A. So this becomes 1 plus sin A into 1 plus sin A, 1 plus sin A whole square, and here we have 1 minus sin A, 1 plus sin A, that is 1 minus sin square A, because a plus b into a minus b is a square minus b square. Okay, so we have root over of 1 plus sin A whole square by root over of 1 minus sin square A can be written as cos square A. The identity sin square theta plus cos square theta is equals to 1, so cos square theta is equals to 1 minus sin square theta. And now root and square gets cancelled from both ends, so this becomes 1 plus sin A by cos A, that can be further written as 1 by cos A plus sin A by cos A. Now as we know, as we know that cos is an inverse function of secant function, so this becomes 1 by cos A becomes secant A plus sin A by cos A is nothing but tan A, and this is the required RHS.